In this video, we're asked to write a method called countBelow that we're going to add to an int tree class. The method accepts a integer parameter which will represent the level that it wants us to look at, and it'll return an integer count representing the number of nodes that exist on that level and deeper. So, for example, we have this tree which has 1 level, 2 levels, 3 levels, 4 levels. So what happens if we call 0 upon this? Well, it will return an illegal argument exception because we can't go any lower than 1 here. If we do call upon 5, here's an interesting case. It has 4 levels, but 5 is kind of the cutoff. And we see that we do reach the bottom is 5 here, and there's nothing below it, so it'll return 0. If we call upon 0, we'll get an illegal argument exception because levels start counting at level 1. There's no level 0 in this method. So let's get started. So public, it's going to return a count, so it's going to be the type integer, countBelow. We're going to take in an integer level, that'll tell us what level we're on. So we need to check to see if the level is less than or equivalent to 0. And at that point, we know that we want to throw a new illegal argument exception. Because we have nothing to look at that point. It's not possible. Otherwise, what do we want to do? Because we're dealing with binary trees, we'll be calling upon a private helper method to kind of help us do the meat and potatoes of this. So countBelow, and we want to traverse through a tree. So we're going to take an overall route. Let's think. We want to look at the current level that we're on. So the way we're going to do that is we're just going to set that to 1, just assuming we're on level 1, and then we're going to pass in the level that we want to hit. I'm actually going to call this target level. No, I'll call it level. I want to call it target level just because it would make it look much easier when I'm not dealing with two things that are almost called the same thing. So anyways, let's get started. The private method is going to be the return type integer countBelow. So returning a count of how many tree nodes are there. So int tree node, int, we're going to look at the current level, and then int target level. Okay, so the base case is we want to check to see if the node is equivalent to null. What do we want to return at that point? Well, let's see. Go to the spec here. Okay, so if the tree is empty or it does not have any nodes at the given level or deeper, it should return 0. So at this point, we're just going to return to 0. Okay, now that we've moved on there, we want to make sure that our current level is less than our target level, so that we can actually start moving up our current level until we get to that target level, and then at that point we'll keep going until there are no more nodes to look at. So if the current level is less than the target level, then what do we want to do? We want to keep calling upon this method by traversing through the left and the right side. So node.left, current level. At this point, we know that we've reached this point where we're actually not going to start counting the nodes yet. Target level is going to stay the same. But we also need to add upon that the other method. countBelow, traverse through the right side, increment the level by 1, and target level will always remain the same. Yeah, okay. In this other case, we know that We have finally reached the point where, so for example, our level is 2. We've reached the point 2, and we now want to actually start counting these nodes. How are we going to do that? Well, we're just going to return 1, because we know that we've hit at least the level there, and we've hit a value of 1 node, almost guaranteed there. Count below of traverse through the left side, increment the level, target level plus 2, count below, node dot right, current level, add 1, then target level. And then that should be it for this. Let me make sure. Okay, so if the level is less than 0, we'll throw in a leave alarming exception. Otherwise, we're going to return this. We're going to say we're going to start at level 1 because we can't start at a level 0. So we start at level 1. We have the target. We pass that in to the parameters here. If we have an empty tree, or if we happen to reach a level that doesn't have any null values, we're returning 0. If our target happens to be target 2, but our level is level 1, then okay, this will traverse through the left side until we get to level 2. Then it'll go down to this. Then it'll traverse down the right side until we get to level 2. And then it'll start implementing this. It'll increment the count based off of how many nodes are on that level. Yeah, that's good. Alright. All works.